A very good morning to all. In today's session, we are going to learn about the conjoint analysis and multidimensional scaling or perceptual snapping. So let's begin with the correlation coefficient. So correlation coefficient is a number which always measures that how the two or more variables are closely related. It always been range from -1 to 1, 0 to 1, or the 0, which always indicates that there is no relationship between any of the variables. So when any of the ranges of values comes under -1, 0, and 1, it always indicates some type of correlation or whether it indicates that there is a relationship between the variables or not. So when we talk about -1, it indicates that there is a perfect negative correlation between the two variables or more variables. When there is a correlation or the value of r is equal to 0, that means there is no correlation between the variables. When the value of r is equal to 1, then there is a perfect positive correlation value between the variables. So let's look up through the diagrammatic presentation and at how it looks like and how the value of r indicates or look like in the pictorial representation. So this is the correlation coefficient which shows the positive, negative, and no correlation. So when we talk about the positive correlation, that means that whatever the dots or the scattered dots diagram on this scatter diagram, the dots which has been shown, it's totally showing the upward sloping. That means the value is equal to 1 and there is a positive correlation between the variables. But when we talk about the negative correlation, these scattered dots, which always goes in a downward sloping, and the dots which are going up, that becomes the positive correlation, and the dots which are going downwards or going down, it remains a negative correlation. That means it's showing up -1. So any of the value of r which comes under minus, that becomes the negative correlation. When we talk about the no correlation, where the dots or the area of the dots is remain undefined, it could be in any, it could be related to the you can say the horizontal line, and which always shown on the screen, that any dots which goes on the horizontal way or path, that ultimately shows that there is no correlation between the variables. So this is a Carl Pearson correlation coefficient formula, which R, that is R is related to the correlation of the value of R, which equals to the sigma x minus x bar into y minus y bar by under root sigma x minus x bar whole square under root y minus y bar whole square. That means x bar is equal to the mean of x variable and the y bar is equal to the mean of y variable. There is an alternate formula which always named as covariance formula, and the covariance formula in respect of the variables x and y is equal to the sigma x minus x bar into y minus y bar by n. In other words, I could say sigma x by n, and n is a total number of observations or the items. Now there is a practical questions which always ask given that there are two variables of x and y, and calculate the Carl Pearson coefficient of correlation using the following data. X, the values has given 1 to 5, and the y is the value is also given 10 to 50. That is 10, 20, 30, and 40, 50. So let's calculate the Carl Pearson or the value of R, and whatever the value of R, that will denotes the exact outcome or the interpretation of result. Now, let's the x is given 1, 2, 3, 4, 5, and the y is 10, 20, 30, 40, and 50. That is x squared. So we have to calculate the value of r. That means we need to calculate the x square and the y square and the xy. As we here in this particular question, we need to calculate the value of correlation through the covariance, that is through the alternate formula, which is a quick easier to calculate the answer, to calculate the value of correlation. So automatically the values of x and y is already given. So the next target is you need to calculate the sigma xy. So sigma xy need, it's automatically it's being given x and y. You have to multiply it one by one and accordingly just add the values and put the value to the formula, that is sigma xy, and that we can easily calculate the value of r. So in this particular table, you need to calculate the x square and y square and xy. So automatically, we need the total value of xy. So 1 into 10, it becomes 10. 2 into 20, it becomes 40. 3 into 30, it becomes 90. 4 into 40, it becomes 160. And 5 into 50, it becomes 250. So when we multiply each and every you can say value of the both variable x and y, we can easily calculate the value, the aggregate value of x y. So once we get the value of 10, 40, 90, 160, and 250, so once we add these value, we get the summation of xy is 550. So let's look up the values of the particular variables and in respect of you can see the table, that is sigma x is 15 and sigma y is 150. So whatever the values has been given like 1 to 5, it's sigma x is 15, and 10 to 50, that means the sigma y is 150. So once we calculate this x square value, that is 55, and y square total value is 5500, and sigma xy, which I already told you, it's 550. So automatically we just put the value into the formula, that is covariance formula, which already shown on the screen. That is the alternate formula to calculate the value of r, that is sigma x minus x bar. So instead of applying sigma x by n formula, you can also use the first formula, that is sigma x minus x bar y minus y bar by n. And first you need to calculate the mean of x, that is x bar, and the mean of y, and accordingly you just subtract the mean of all of the x variable, and same the mean of y subtract all of the y variables, values of y variables. So automatically put the values and you will easily get the value of r. But in this question, that is sigma xy by n, so automatically when we talk about sigma x by n, that's sigma xy is 550 and the value is 15, that becomes the value of r is 36.67. So 36.67 is the value of r. Now, these are the range of correlation coefficient and the level of correlation. So, automatically, when we talk about the 0.080 to 1, it indicates the very strong positive correlation, and 0.60 to 0.70, it indicates the fairly strong positive correlation, and so on. The one of the weak positive correlation when the ranges comes under 0.20 to 0.39. And when we talk about the negative correlation, that means the -1 to or minus 0.80, it's a very strong negative correlation, which reaches to a weak negative correlation is -0.39 to -0.20. It is a weak negative correlation. There is also another category that is very weak negative, a negative correlation, which comes under 19 minus to minus 0.01. So these are the ranges of the correlation coefficient and the level of correlation, which indicates, or if you have any of the values which comes under these ranges, you can easily indicate the level of what type of level of correlation would be. So, and accordingly, the diagram could be drawn based on the values, based on the data which has been shown. So, this is a graphical representation where the strong positive correlation, if you look up the dots, which is the dots which are showing in the upward sloping, that would be the strong positive correlation. When we talk about the weak positive correlation, where the dots, it's not exactly going up to the exact upward sloping. It could be shift to rightward, it could be shift to downwards, it should be come to the more you can say far wider or longer from the particular state dots, and it becomes the weak positive correlation. When we talk about the strong negative, that means whatever the dots have been shown on the ground, it should be a negative or downward sloping. When we talk about a weak negative, it is downward sloping, but somehow it is come to the nearest to the dots, two dots, it's come to the far distance in the dots, but it's showing a negative downward sloping. So it becomes a weak negative correlation, a moderate negative correlation. It is very near gap to the dots, which always slowing downwards. That becomes the moderate negative correlation. And no correlation anywhere, whether it would be the upward sloping dot or the downwards or the horizontal line, the way of horizontal line, the dot exists. That means there is a no correlation between the two or more variables. So this is how the like through these ranges the graphical representation could be drawn, but it could be the based on the values, the based on the data and information is given to you in the question. Now we can come up to the testing for the significance of the correlation coefficient. So automatically when we talk about the testing for the significance of correlation, totally determines that what sort of relationship between the two variables, which is totally based on the sample data of the population as a whole. And when we talk about the testing of the significance of the value of R, we use the one of the best tool of statistics called the t-test or the t-statistic test, which always aimed to assess whether the correlation coefficient is significantly different from zero or not. So while applying or before applying the statistical tool, that is t-test, we need to formulate the hypothesis statements. So it could be a two main types, that is the null hypothesis and alternate hypothesis. So the null hypothesis, it shows there is a no linear relationship between the two variables in the population as a whole. That means the correlation which is equals to correlation coefficient, that is equal to 0. But when we talk about the alternate hypothesis, that there is a linear relationship between the two variables, that means in the population as a whole, that means the correlation coefficient is not 0. And we need to prove that whether there is a relationship or there is no relationship exists between the two variables using up the statistical tool, that is t-test or the t-statistic test. Now these are the steps that how you conclude the results while using up the t-statistic test. So these are the various terms which will be used to calculate the value of t and how you can interpret the results of the t statistic value or the t calculated value. So there is a formula that will be used to calculate the value of t. The t statistic is calculated using the formula that is t is equal to r into n minus 2 whole square by n1 minus r whole square into 2, where the r is a sample correlation coefficient and the n is a sample size. Now, when you came to know the formula that okay, this is a formula used to calculate the value of t or the t calculated value. Now, this is the next term that you need to calculate it, use to conclude your result, and that is the second step is determine the degree of freedom. So degree of freedom, which stands DF, which call the n is a sample size minus 2. As there are two variables, so automatically, as according to the mathematical or the statistical rule under this test, that is n minus 2. So next is find the critical value or the p-value. So automatically critical value, critical value is always termed as a table value, and there is a t distribution table where we need to calculate the t table value at the significance level. Let me take an example of significance level could be, which always, as I in the previous session I already told that the significance level is also called the alpha level, which termed as a point of 1% to 5%. So either you can take the 1%, either you can take the 5%. It's absolutely it's mentioned in the question, or either you can opt 1% or 5%. It's totally depend on the choice that you are willing to take up to conclude your results or interpret your results. So when you compare the calculated the formula which you have used and whatever the value has been achieved and been calculated, that calls the calculated t statistic value. And once you compare the calculated t value using up the formula from the table value at the significance level or alpha level, that is zero point 0.1, that is 0.01 or 0.05. So in this particular, we take up an example, or suppose the significance level is 0.05 and using up the degree of freedom. So once we estimate the table value from the t distribution table where the significance level is shown on the row and the you can say where the significance level shows in the column side, and you can say the value, the degree of freedom shows in the row side. So accordingly, the value, whatever the degree of freedom would come up, accordingly, you can check on the exact value under comes 0.05, which comes under column side, and accordingly, you can estimate the value of the table value. Next one is p-value. So calculate the p-value, which always relate to the value of t or the calculated value of t using the statistical software. Either you can use the T Strata software, you can use the SPSS software. So the p-value will be calculated after comparing of the value of or the calculated value of t using the statistical softwares or the t distribution table. So automatically what the p-value refers for. The p-value represents the probability of observing the t statistic value, which is an extreme value as a one calculated, where it always assume the p-value is always assumed that the null hypothesis is true. So if any of the value which always less than the zero point 0.5 or the alpha value, that means the null hypothesis will be true. So this is how we can conclude the results based on the calculated value and the table value. And the p-value will be calculated based on the calculated value, that is of t statistic value. So let's take an example to understand about more and how you can conclude the results when we apply and prove our hypothesis, whether it is accepted or rejected. So let's make a decision. So these are the rules of the t-test. If the calculated t statistic falls outside the critical value region, that means if the p value is less than the significance value, that we reject the null hypothesis. That means if we reject the null hypothesis, that means there is a relationship or a statistically significant relationship between the variables. If the calculated, or in other words, we could say if the calculated t value is more than the table value, that means we reject the null hypothesis and the relationship exists between the two variables. But if the calculated value or the calculated t value is less than the table t value, that means it fails to reject the null hypothesis. That means we accept the null hypothesis and there is no significant or statistically significant relationship between the two variables. So it's the decisions will be taken if the values of the calculated t value and the table value is available to you and you can easily conclude the result statistically. So let's take an example to understand. Suppose the t value is 1.506 and the t dash, that is the table value, is 2.306 and the degree of freedom is 8 and the significance or alpha value or alpha level is 0.05. So automatically when we talk about here, that means the calculated t value is 1.506 and t dash, that means it is a table value or the critical value or the tabulated value of the t distribution table, that is 2.306. So automatically when we conclude our results, that means the t value or it's the begin. In other words, we can say the t statistic value is less than the critical value or the tabulated value, that is t dash. So automatically when the t value or the calculated value is less than the table value, then unfortunately we have to reject the null hypothesis. That means for any of the relationship between the two variables. So let's say if we need to find out the correlation between the weight and height in the sample of 10 newborns baby. So automatically when we took up the compare the values of the calculated value and the table value, then unfortunately we have to reject the null hypothesis. So automatically when we reject the null hypothesis, then in other words the null hypothesis is accepted. So automatically if the t value is less than the critical value, so we do not reject the null hypothesis. That means the Pearson correlation coefficient of the population is 0. That means we reject the null hypothesis. That means there is no relationship or there is no significant relationship between the two variables between the weight and height. That means the sample size of 10, which has been shown in a particular example, that is very small, and it could be, if the sample size could increase, then definitely it could find a significant relationship. So it means if we reject the null hypothesis, then ultimately there is a no significant relationship between the weight and height. So this is the overall outcome. This is the overall interpretation when we compare the two values, which is based on the two main rules when we compare the calculated and the calculated t value and the tabulated t value. Now we can talk about the practical applications of correlation. So correlation analysis is used in the real life as well to understand the relationship and make the assumptions accordingly. It also helps that in what direction the relationship goes, and it could be positive, it could be negative, it could be non-existent as well. And such knowledge of the correlation is valuable when into various fields like economics, social science, psychology, and in fact, everyday daily life situations when you are willing to take up or prepare any decisions related to a real life scenarios. So let's take up the different perspective like economics. We have to analyze the relationship between interest rates and the investment spending. So whether there is a correlation between the employment and the inflation rate as well. Social science, we always put on study about the income and the educational achievements and or in relationship between the social support and the mental health of the consumers as well. When we talk about the business, we always talk about the assumptions. We always talk about the prediction, whether there is any sales that can be achieved after investing a huge sum of money on a new products. So, and in other words, we can talk about any related to find out the relationship between the website traffic or the customers' conversions into a sales. So this is how we just assume the statements or prepare a declarative or the predictive statements, and accordingly with the help of the sample data, we just analyze and conclude our results as after using up the t-test. Everyday life, you can also noticing a correlation between the foggy days and the attack of busyness, and observe a relationship between the any exercise or body fat percentage in everyday basis. Research, it also identify the relationship between scientific studies as well. That means a new medication and the patient outcomes as well. So when there is a new researches in terms of new medicine or new vaccine into a cancer or any of the new disease, definitely research also plays a very important role, and how the correlation tool is also exists to identify whether any correlation between it or not. So these are the real life examples in the form of a chart where the Hembin 2024 is almost says the positive correlation occurs when there is a significant linear relationship. So if there is any increase in the one variable, so definitely it will increase in the other variables. So let's talk about exercise and health. So exercise and healthy diet is a strong relationship or association with excellent overall long lifespan period. Let's talk about education and income on an average level. The more and more educated an individual is, the greater their income potential would be. Climate change and droughts. So there is a correlation between the intensity and at what level of intensity of the climate change and the frequency of floods and the droughts come up in India. Next one is the gas prices and the miles driven. As the gas prices increase, the drivers is always tend to reduce the number of miles they drive. So automatically, so there always be an increase to increase or decrease to decrease relationship correlation exists in the real life scenarios as well. Now we can come up to the next concept, that is conjoint analysis. When we talk about the software, the statistical softwares, that means the statistical What is SPSS? Is a statistical package of social science. So conjoint analysis is one of the statistical tools which always been used to identify, to understand the consumer preferences, the consumer perceptions and behavior, whether there is any trade-off war between the different product attributes in the minds of the consumers, how what type of sort of behavior could be when they are trying to try when they are try to buy a new product. It also helps the researchers or the newcomers who try to determine which attributes of or factor are most important to the consumers when they are uh, look up or observe a different product varieties, and what and how different levels of those attributes will impact their choices, will impact their interest as well. And SPSS software will offers such analysis, such modules, which always gives the user that how they will design the conjoint analysis when well to understand the behavior, the changes of the behavior, the perceptions, their preferences, and accordingly they will you can say prepare the surveys, analyze the data, and interpret the results so that they can read, they can understand, they can gain what would be the insights in it to understand more and more about the consumer behavior in terms of the different varieties of products available to them. Next is what conjoint analysis does. It always reveals preferences. Why it reveals preferences? Because the main aim of such analysis is to identify the what product attributes are the most important to consumers. What factors are more important while deciding their preferences towards the products which are available to them. So if you go into a shopping complex and if you go to the males or the female counters, you can see a varieties or the different product attributes available in the complex. And now there is a time to get what perspective or what important factors to consider to buy the products. So this analysis works to identify, to understand your perceptions, your preferences in terms of buying the products. So this analysis always work to understand. Next one is it shows trade-off. It reveals how the consumers weigh that different factors towards different attributes against each other when they are making up any decisions relating to the purchase of any product. Next one is determines the optimal features. Of course, such analysis which also helps to identify when they combine a product attributes that these combination, what sort of product combinations or product of combination of product attributes are the most desirable, are the most important or significant to the consumers. Next one is it supports the product development. So what are the insights which a particular researcher tried to gain from such analysis can be used to improve the product design, the pricing strategies or the marketing strategies so that they can able to understand their perceptions and preferences towards different product attributes or characteristics. So how it works, it could be worked through three main tools. It could be a survey design you can conduct. You can also conduct a choice task. You can also apply the statistical analysis for such, you can see to conclude the results of the preferences, choices, etc. So survey design researchers create a survey that presents the respondents with different products profiles, each which are totally varying the level of different attributes as well. Choice task respondents are always asked to choose the different preferred profile or rank them in order of their preferences or choices. Statistical analysis, it always such in such software, such analysis or modules using the statistical methods to analyze. So when we talk about the conjoint analysis, we can also use the Carl-Pearson correlation coefficient. We can also use the t-test. We can also use the regression analysis tests. We can also use the chi-square test to analyze the choices and what factors which actually are more important when the consumer making any buying decisions, and its relative importance of each attribute the consumers make, and what would be the preferences towards different product attributes levels. Benefits, it's a user-friendly interface. The SPSS provides a very user-friendly interface that the software will easily design the conjoint surveys, and they can easily analyze the data that you collect, and just put the files, Excel files into the softwares, and they can easily within a second they can analyze the results after applying the statistical tool in it. Next is powerful statistical tools. Of course, such analysis offers the advanced statistical techniques for analyzing the choice data and interpreting the results. So automatically it always shows a clear reporting. The SPSS softwares generates a detailed reports, and of course such reports can also be used to communicate their findings to the stakeholders of the organizations or to the readers so that they can understand that how after using such analysis or using the software and applying the statistical tools, these are the results that has been come up and which are very useful for the organizations to predict their future or to predict their any market trends or the future trends accordingly. So SPSS software's conjoint analysis is a valuable tool for all of the researchers who are actually main interest or aimed to understand and study consumer preferences and make an informed decisions about any of the product improvement, development, any of the sales and marketing strategies they are willing to implement or formulate. And this analysis tool, this term, conjoint analysis, through using the SPSS software, applying any sort of appropriate statistical methods, definitely it come up to any of the informed decisions related to the product development and the marketing strategies. So this is one of the example and what process to be used, that how to do a conjoint study relate with respective of this example. So the first step is break the products into attributes and levels. So if you look up, we have classified the products into attributes and levels. So we can talk about the brand, that is Ford, Cleveret, Dog. We can also classify the more attributes like type, engine, price. So when you have any product or any brand and you just classify that brand into the levels, into their attributes, so definitely then you can easily apply the conjoint analysis concept or the framework to analyze and conclude the overall results. So to conduct a conjoint study, you have to break up your product or service that you intend to research into any of component. So if I have taken the three brands, so I have to study and break into such brand into type, engine, and prices, and accordingly, that means it is and accordingly I can research into all of these aspects, and of course, whatever the component or the level of attribute that you choose for any of the product or brand, you have to classify that components as well, and that components will also call an attributes or the levels of that parameters. So in this example that you can see in an image above, so it's broken the components of a car into attributes of interest for our experiment like brand, engine, type, and price. And for each of the attributes, we have also defined the levels that we really want to evaluate. If you look up if you look at the image where the brand type, engine, and price, these are all the attributes, and once we just classify these attributes into the levels, that becomes the engine. There are three type levels we have classified. The price we can categorize into four parts, type into two, brand into three. So this is how and we have to classify a product into attributes or levels, and then the time comes to apply the conjoint analysis software, which always creates a different product combinations. As you can see in the brand category, there are three main products of the car using the levels from each attributes. So each profile is always being made up of the multiple conjoined product features like brand, type, engine, you can see color, and systematically it will also classify the levels of the brand, the levels of the types, and the level of engine, the level of colors, level of prices, and accordingly we can start our analysis, which called the conjoint analysis using the SPSS software. So you can look at that how the analysis is to be done. We have categorized into brand, type, and engine like this, and we have to select any of the alternatives so that we can easily analyze our results. So if you were in the market for your next vehicle and these are the only alternatives, then you have to choose any of the alternatives in which you are actually willing to opt. So obviously, if we have a selected this, so definitely we have looked the price also. We have looked up the engine also. We have looked up the type also. So accordingly, we have looked the most important factor while making up a decision related to a purchase of any product or let's say a car or a vehicle. The next step is survey analyst builds a model that quantifies the market preferences. So automatically the final step in the process is where you discovers and realize the insights from the data that we have collected. So whatever the data we have collected, these are the brand type, and accordingly the numbers, the main data samples that we have collected related to the brand type, accordingly we can show up in the charts, in the graphical representation, so that the readers could easily understand. So whatever the model, the bar chart model, the pie diagrams models, you can easily use up and easily you can draw the diagrams so that the survey can easily portray what would be the exact figures so that we can choose and make up prepare the meaningful results from the data, from the sample data that the researcher which has been collected. So these are the conjoined software as immediately having the results where the labels, the brand and the time where the standard errors has been estimated, the utility, the correlational values has been estimated, and accordingly we can conclude our results. So these are the results which has been estimated using the uh, conjoint analysis SPSS software, and these are the final results that under the brand the standard errors which come up to the 12.56, so that which is the highest standard error, so that particular level will be chosen. So this is how the interpretation of the results after analyzing the data will achieved, and this is a game where the researcher gain any of the insight and conclude the results. So the conjoint software includes a statistical model which always considers whatever the available product options, whatever the alternatives available to the consumers, and automatically the consumers decide the most desired option and attribute which impact our on a customer choice. So one of the primary reasons of using such analysis is to gain insights strategically which relate to the product pricing, product feature development, brand and package design, marketing, messaging, validation. So this is the main purpose since the research has been conducted and the product that is car or vehicle has been classified into four attributes, that is brand, type, you can say pricing and engine. And the main purpose is to identify that all decisions to be taken related to business on these parameters, on these attributes, and that's why the statistical software results has come up dependent utility. As you can look up, the utility has been decreased from first label for to claronet, it's cleverlet. So automatically the standard errors is also being reduced from 12.56 to 3. That means the usage of these cars or vehicles has dramatically decreased, and it's that there is a statistically you can say a relation between the usage and the choice of the level that the consumers choose. Same in the type also, as the utility of the vehicle has been reduced, so definitely the type, the truck and the SUV is also being decreased. And ultimately, standard errors is also being decreased. That means there is a strong correlation between the type of the labels and the vehicles as well, and their usage. So this is how you can conclude your results and using this analysis, and accordingly you can apply such studies, such analysis using the software, statistical softwares in your research studies as well. So look up the results. Another example, there is a flavor, the utilities. We can use up the utilities of food flavor of any of the food product, consumer products. There is a flavors has been given, and the statistical calculations has been given what would be the utilities, because we are talking about the products. So of course the usage estimation would also be estimated by the software. What would be the standard error? So these results would be calculated once to collect the sample data, and then you can collect the sample data, then you can put all of the responses accordingly in an Excel sheet, and then it goes to for the analysis. So what sort of analysis a researcher has to you can say has to complete, and accordingly they and has to adopt accordingly they can do that. So this is how the results has been correlation result, that is 0.795. That means there is a strong positive correlation between the usage towards the different products and their particular parameters that a particular consumers prefer while buying any decisions, while buying any product or not. So this is how then you can conclude. So before you need to prepare the survey, questionnaires, then what will be the responses that you get? You just make it entered into an Excel sheet. Then the analysis is to be done through the SPSS software, and just have a sample of these results, which we get. A researcher will gain insight through these results using up the conjoint analysis tool using the SPSS software. And correlation is one of the statistical tool to do such analysis, that is conjoint analysis. So these are the applications. So conjoint analysis should in a marketing. So you can prepare the questions related to a marketing, any of which can relate to any of the features to offer in a product or service. What would be the price of the product? To whom you target while you offering such products. So this type of questions which always helps to conduct a market research, which you can take up a sample size of 100, 200,000, and accordingly you can conduct a single market survey as well. Conjoint analysis is also being used for pricing research. So such analysis can also be used to figure out what would be the price and charge of a product and service so that they can deliver the most desirable value to the consumers or the customers, which ultimately increase the revenue or profit to the organization. And definitely it will also add on a value to the whole business dilemma. So automatically it could be a great idea while you asking the question that what would your willingness to pay for a new product, and that this sort of research could be a critical because nobody knows that what the other person would willing to respond your questions or not. So it would be feel difficult to answer, and if any of the subjective question, it could be difficult for the respondent to answer in brief as well, or it will remain unsolved. So this is also the one of the issues in it, but it is also you can prepare the questions through emails, through your mobiles, through your WhatsApp, in Telegram, and share the questionnaires through Google link, and ultimately they can be easily get the response, and accordingly you can conduct your study. Conjoint analysis and product development. So of course, product managers want to understand, it's all about to understand the customer needs as well. So any of the tests you can use about the ABC analysis tool as well. Conjoint analysis also used for the branding, package design, and product claims. So you can use a choice-based conjoint questions, any sort of precision. You can see you can make it an excellent solution once you come up with the branding, package designing product. But it could be done once you get the references, once you get the feedback, a realistic feedback and responses from the customers in this real world. So automatically you can easily work on the colors, on the design, on the messages. It could be an emotional appeal, it could be a non-emotional appeal or the rational appeal, and how it works for your brand. That is very important to analyze. So you can use such tools, conjoint analysis tool when in your market research as well. It also used in healthcare, is also used in environmental economics as well. So there are plenty of medical tools we can use. We can also use the environmental where the investment put on too much to conserve your environment. So that is also to understand the real life scenarios. Next is multidimensional scaling. So multidimensional scaling, or we can talk about the perceptual mapping, which I already told in the beginning of this session. In the words, we can call it a positioning mapping. So it is a multivariate, you can say, analysis statistical technique, which is mainly used to measure the human perceptions of what should I think about a new product. So if If someone researchers trying to measure my perception at the point of time while making choices or making a preferences towards the products and the brands, then we can talk about the multidimensional scaling. So it is mainly concerned with the spiritual representation of the relationship about my behavior, about my preferences, about, or in other words, my perceptions. That's become. So if I study the perception along with the preferences, behavior, while for the different products and the brands, we use the multidimensional scaling. So multidimensional scaling is a very common tool to use in marketing to identify the various key dimensional areas to evaluate the consumer complaints, the products, and the choices of the customers. So the common application is like how we compare the physical qualities, the perception of the potential candidates and issues, or the political candidates, we can say, how we can assess the cultural differences between the different groups as well. So when we study different groups, different perceptions, different tastes, different preferences towards the products and brands, we always use the multidimensional scale. The main purpose is to map the objects related to their performance position. So, what sort of position the exact product holds after analyzing the consumer preferences or the preference perceptions as well. And that's why once we, or in order to examine exactly such map, we can make up, it's called the perceptual map or the spectral map when it comes to study the relationship between the particular variables. So it always helps to identify the attributes which influence how consumer perceive, how consumer assess the brands or products. We also try to enable that what types of sort of position the different products or brands could take on the basis of the attributes chosen by the customers. It also helps to prepare the virtual map, but perceptual map, which always indicate the location of the brands and the products which are based on their attributes. So this is an example, the basic mechanics of the multidimensional scaling, which is useful. A very simple example I could take up to understand this concept. So distance matrix shows the distance in kilometers between 4 Australian cities. From these distance alone, we can reconstruct the map which shows the distance between the cities. So when we talk about the different cities, when we talk about the different countries, and we study the different countries based on one attribute called kilometers. So this is how we use the multidimensional scaling. So let's have a diagram. So this is the data where the three you can see cities, that is Elbitring, Brisbane, and the Perth. That is the Sydney, Elbitring, and Brisbane. It's Brisbane. So there are 4 Australian cities, and the particular kilometers values has been given. But there is a main common city, that is Elbitring on the right, on the left side, and of course on the y-axis, on the x-axis. So we can take a main common point which always associate the all of the other three cities, and this is the chart that we have drawn, that is called the multi-dimensional scaling. So Adelaide is a common point which connected to every Australian city, and this is how we have drawn. So automatically Adrian, that is 2118 Perth. So automatically from Adrian to Perth we can draw. Then accordingly Perth to you can see Bliss Lane, then Bliss Lane to Sydney. Then accordingly we can draw this scaling. So this is how the SPSS software, we just put this data and we just put the name of this tool, conjoint analysis or multidimensional scaling. You have to draw the diagram. Automatically, the SPSS software draw this diagram immediately. So this is how we can draw, taking up a different cities in a different products based on their attributes. It could be the taste, it could be the you can say the features, it could be the any sort of any level of you can say attribute, and accordingly we just prepare the data in the Excel sheet and we can use the SPSS software, and accordingly we can draw the diagrams and analyze the results. So this is the way that how we can use up these two main important analysis tool using the concept of coefficient of correlation, which also I can show the results of the SPSS where the correlation results is shown, and this is how these analysis or these concepts will be used for the data analysis in market research. So this is how we can analyze through using of the SPSS software. These are the results which I have already shown on the screen. This is how the results has been derived from the SPSS software, and from the result you need to interpret the results, you can say in depth or briefly. So that's it for today. Thank you so much for listening this lecture. I will come up with the more and more interesting and important topics in the upcoming session. So till time, thank you so much and namaste to all.